Howdy, welcome back. So we'll continue with a brief discussion on kind of the importance of declaring our destructors virtual in a inheritance scheme. If you've kind of figured out why this might be the case at this point in the lesson, awesome. If not, no worries, we'll jump through this. And we're going to do so with an example. So we've got Bubby the cat, Polly the parrot, both now are allocated on the free store, and we have a collection of animals. So animals is going to be a standard library vector whose each element is going to be simply the address of an animal object. So in the case of pushing Polly and Bubby back to this vector, those when we interact with them through the vector, we're going to be interacting with their base component and not the actual whole object as a whole. We're looking at them through the lens of an animal and not of the derived type. So we put them on the free store. Now we're going to run through over here for each animal, and we're just going to deallocate the memory associated with them. For each animal and animal, delete animal. Interesting thing to point out is the type of pointer is a pointer to an animal. So at the end of an object's lifetime, the destructor is responsible for releasing all resources still owned by an object. With this in mind, what are the implications of the following code if any of the derived objects own a resource? And the key here is to recognize that which destructor is being called here, because you're calling delete on an address, but the type of address or the type of the pointer, excuse me, the base type of the pointer is of an animal. What are the implications of that? Well, the compiler is going to provide us with a hint. It's saying, warning, delete called on animal that is abstract but has non-virtual destructor. Why is that problematic? Well, if any of the derived objects, such as Bubby or Polly, owned a resource, such as a dynamically allocated object, we would have a memory leak. Why? In the code to the right, we're looking at cat and parrot objects through the lens of the base class animal, and it is through those lens upon which we're requesting that their memory is deallocated. We're calling delete on an address. The type of the pointer is an animal. So technically we're attempting to return an animal and not necessarily a cat or a parrot. So consequently, when we call delete on a pointer to an animal, only the destructor for animal is called. So here for both Polly and cat, only the animal's destructor is called. And that's problematic if Polly or Bubby owned, or so if the cat or the parrot type owned some sort of dynamically allocated resource, because the destructor for cat, so cat, or the destructor for parrot are not called when we're calling delete on a pointer to an animal. So the derived class's destructor is not called. So how can we resolve this? How can we ensure that the destructor for, say, an object of the derived type has its destructor called if we're looking at it through the lens of the base class? Well, very easy. Just say that the destructor is virtual. So to avoid the memory leak that would otherwise occur, we need to make the destructor virtual to ensure that the derived typed object's destructor is called when viewing that object through the lens of the parent. After doing this, the compiler no longer complains, and provided a proper implementation of the destructor for the derived class, we would no longer have a memory leak. So here's a rule of thumb. If you have a class with a virtual function, it probably needs a virtual destructor. If the class has a virtual function, we probably look at the derived class through the lens of the base class. Since pointers are a common way to achieve polymorphism, remember, we only get that polymorphic behavior if we're looking at a derived object through the lens of the base class. To do that, it's either through a reference or a pointer to the base class type. Remember, if we write something like animal A equals, say, Bubby, That was object slicing. That's creates a whole brand new object, which is not what we were going for and what we couldn't actually do if we had a pure virtual function, because remember, we couldn't have objects of the type if the base class is an abstract class. So since pointers are a common way to achieve polymorphism, the derived class likely was allocated with new. If the derived class is manipulated through a pointer to its base, then it is likely going to be deleted through a pointer to its base, as done here. Therefore, we probably want the destructor of the derived object in addition to that of the base to be implicitly or indirectly invoked when that delete is called. Therefore, we should always go ahead in this instance and label our destructor as virtual.